Well, hello everyone, welcome back. This is the second of our video lecture series. This one is on conditionals. Conditionals are really just a way for computer programs to make decisions, and so they can actually get quite complex. But we need a way to act differently on the conditions or the status of the data that we have right now. And conditionals are the way that we do that. It's going to be a really crucial part of your first assignment. So let's take a look. All right, well, as mentioned, conditionals are a way for our computer programs to make decisions. Depending on the kind of data we have or the kind of environment in which our computer program exists, the computer program may need to behave differently, and conditionals are the way that we make that happen. This happy fellow, this Victorian, his name is George Boole. He was a 19th century mathematician who moonlighted, I guess, a bit as a psychologist. He felt that the brain functioned really by evaluating truth claims about the world around us. So two things were true at the same time, that was an and. If one or the other of those was true, then that was an or. If it happened to be false, maybe we would negate that with a not. And so he felt that this is the way that the brain really worked through things. That isn't true at all. And so what happened, especially around World War II, as computers were really being developed, computer scientists are a bit like dumpster divers. You know, they like to hang out in alleys late at night and they find things that other people are throwing away. And one of their favorite places to hang out is behind the psychology building. We're going to see this again before we get to the end of the term. And as soon as psychology throws something away, the computer scientists are like, well, you know, maybe we can use that. I think that's really great. So they pick it up and they take it. And this idea of Boolean operation was one of the things that they stole. So according to George Boole, right, every statement is either true or false. There's no medium in here. There's no kindas or maybes or partlys. It's just either true or it's false. And every computer language today really understands that. It's a fundamental part of a computer language, as we're going to see. And Python 2 knows true and false. And in fact, just as a passing moment here, just a note, Python spells true and false with capital T and capital F. Right? All right. So because in Python we need sometimes to take different actions depending on our circumstances, the conditional in Python looks a bit like this. There's one here. This is an in operator. We're going to see this a little bit more, especially next time in the next lecture. But this is the foundation of Boolean operation here in Python. So the if is the keyword that signals to Python that we're about to make a decision, and that it should evaluate the keywords from if to the colon at the end of that line. And that is a Boolean expression. No matter how complicated that thing is, Python will decide whether it is either true or false. Again, no maybes, no partlys, no sometimes, just either true or false. Now, if that Boolean expression evaluates to true, then the indented code underneath it will be executed. If the Boolean condition evaluates to false, that indented code there will be skipped. We just won't execute that at all. That indented part is called a block or a suite. And in Python, that indentation is required. This is not optional. Python needs that to be there. And if it isn't there, Python is going to complain to you a little bit and it's going to give you an error. And as we go through the term, I'm sure we'll see that many, many times. Now, that indented block or that suite can be as long as we want it to be. Here, it's one line, but it could be 10, 100, it could even be 1,000 lines long. Well, that's not going to be very good code, but it could be 1,000 lines long. Python doesn't care. What matters to Python is that when that conditional is true, every statement in that indented block will be executed, no matter how long that block happens to be. Right? And you will notice too that there is a colon at the end of that Boolean expression. That is not arbitrary or optional either. That is necessary and it has to be there. And if you don't have the colon there, Python is going to complain about it. So for those of you who have come from other languages, especially curly bracket kind of languages, Python doesn't use any of those. And so the combination of the colon and an indented block is crucial to the syntax of Python. If that Boolean test at the top happens to be false, we can tell Python what to do in that case. And so we create a second block with the keyword else. You'll notice there's also a colon there, not optional. So in this case, if there is truly an A in the word apple, and there is, then that first block will be executed. But if that Boolean test at the top, A in apple, if that happened to be false, Python would skip the first block and go to the second block and execute the second block. And again, it doesn't matter how long that is. 1 line, 10 lines, 100, doesn't really matter. Totally fine. However, notice this really, really consistent use of colons and indentations. This is part of the structure of Python. And Python is adamant that we do these properly. These things are not optional. If Python wants it to be there, we have to put it in there. This isn't just like, oh, I didn't feel like indenting something today. Python's like, too bad, screw you, indent it, right? It's going to be very adamant about that sort of stuff for us. One of the really important things when we move into Boolean conditionals and Boolean tests is to understand the difference between the single equals sign and the double equals sign. In the last lecture, we already talked about the single equals sign. We said it's a transitive verb, right? Transit moves things, bus, transit, public transportation, transits you from point A to point B. And in Python, the single equals sign is a transitive verb. It moves something from the right-hand side to the left-hand side. But equals equals is different. It is a Boolean test that says, true or false, does the thing on the left have the same value as the thing on the right? True or false? So double equals will always evaluate to a Boolean. It will always evaluate to true or false. So when we do an if statement, you will often see that double equals in the conditional. By the way, if you're used to a programming language that has a stricter version of equality like the triple equals sign, Python doesn't have triple equals. Python uses the word is for that. So in a triple equals conditional, that says, does the thing on the left and the thing on the right, do they have the same value and are they exactly the same data type? Python uses is for that. And it's probably the case that during the course of the semester, we might not ever really need the really, really, really strict equivalence of is. But we'll come back to that later if we need it. So here's an example of Python behaving differently depending on what the name is in that value, in that variable. So here I've created a variable called name. I just put Goofus into the string, and I'm testing. So I'm asking, does the value in the variable name have the same value as the string called William? If that's true, then I will print to the screen, do people call you Bill? We can see here that is not true. So in this case, if I execute this code, Python will skip that first block and it will go to the second block and it will say hello and then concatenate the name on the end, which is Goofus. So it will say hello, Goofus. We can create increasingly complex logical structures, and Python has an elif keyword. You'll notice that it's actually else if, but we take out a couple of the letters, and so Python calls that elif. So This is a more complicated structure, but you can kind of see how that's going to function. So the first thing Python does is it checks this. Is the value in the bucket called name identically Boolean value to the string Marlow? If that's true, then we'll print Hello Kit to the screen. And basically we'll be done at that point. The rest of it will be skipped and eliminated. However, if that first conditional is false, then we drop to the elif and we check this if conditional. So we check to see if the value in name is the same as the literal string Johnson. If it's true, then we'll print Hello Ben. But if that's false, we will fall through all the way to the end to the else at the bottom. And this is the part that will be executed if the other if the other ifs earlier fail. Then we'll just bottom out down here, and we'll finally perform that one. Now, one of the things I want to mention, this is totally a personal issue on my part, but you will see it as I write code. I kind of, I'll just admit this, I don't like elifs. And so in my own code, I very rarely use them. Occasionally they're necessary. You really have to have it in certain places. But just as a personal note, you'll notice when I get to really complicated conditionals, I probably don't really use elif very often. If you like him, great. More power to you. Just use them. This has nothing to do with correct Python or incorrect Python. I'm just saying, as a personal note of preference, I tend not to use elif very often, but that's okay. You can use it all you want. We often think of the Boolean operators as just being and or, and not. And especially if we're used to search engines, these are the classic 3 Boolean operators that we get. But in Python and other programming languages, there are a ton of them. And in fact, we can force things into Boolean true or false that aren't even really maybe intended to be Boolean true or false. But let's just go through these really quickly, because these are some of them that you'll see as we go through the rest of the semester, and that you'll see in other Python code as well. We've already talked about the one at the top here, which is that the double equals sign means is equal to, right? Again, single equals is a transitive verb, moves the thing from the right to the left. Double equals is a Boolean test. It says, are these two things equal? Or do these two things have the same value, yes or no? We can ask the opposite version of that. Are these two things not equal? And in that case, we use the exclamation point as a representative of the word not. Now that'll work almost everywhere. We'll notice here in just a minute, Python actually does have the word not spelled out as well. But not equal is almost always written as exclamation point equals. And that makes some sense because the Boolean test for equality is a 2-character unit. Equals equals. So all we're doing is replacing one of those 2 sequence characters. We're replacing one of them with the exclamation point, which negates it. So exclamation point equals together, no space between, means not equal to. Python does have the keywords not and or. They represent the same kind of Boolean stuff that you would expect them to be. There's some mathematical ones too, right? Which you're probably familiar with from some algebra or some other places. Less than equal to, greater than equal to, all of that sort of stuff. The one Boolean operator that we were playing with just a moment ago, and we're going to see this again in the next slideshow when we get to more complex data structures, is the in operator. In is a Boolean operator that is either true or false, but what it asks is, does the thing on the left occur somewhere in the sequence on the right? So we were asking whether the letter A is in the string apple or not. And the answer to that is true. A is in apple. Here's a case if we wanted to negate that where we use the word not. And we can say, is A not in apple? That would be false. So we can ask whether the thing on the left is not an element of the string or the sequence on the right. We're going to see this again in the next slideshow, where we really start to talk about sequences, lists, and dictionaries, and some other data structures that are very useful but less common, like sets and tuples, for example. And again, just as a repeat, Python does have the keyword is. And what that really means is it's the strictest possible kind of equivalence. And technically under the hood in Python, what it means is that those two things literally occupy the same place in memory. So we use this a lot with object-oriented programming to see if two objects are actually the same thing or not. In other languages, they use the triple equals for this. It's the strictest form of equivalence, and we probably won't need that during the rest of the semester. But I did want to tell you about it because there are some tutorials out there on the web that assume that is and the double equals are the same and that they're interchangeable, but that's not really true. So I hesitate I hesitate to bring that up, but I want to forewarn you about that. If you're out and about in the wilds of the interwebs and you see something and they're like, is and equals, double equals are the same. Like, no, they're technically not. Is a much stricter form of equivalence. And when we get to, or if you get to more sophisticated things like object-oriented coding, you'll understand why we need a stricter form of equivalence. All right. Well, let's jump into the terminal window and do a little bit of these exercises. All right. Well, here I am out of my desktop. I have put in a little script here. I'm using Sublime Text today. But again, whatever text editor you like to do is terrific. But you'll notice, obviously, one of the benefits of working with a professional text editor is that you get this really beautiful color coding. And so once you get used to these colors, and they might be different in your version, but as soon as the colors go a little bit wonky, that's probably where an error is going to happen. So the color coding becomes really, really, really useful. This is exactly the code that I had a little earlier in the slideshow. This is an if, elif, else kind of a conditional. I just added another line here, so I put a print statement here on line 5 so that I can echo that out to the screen, print that out to the screen. And what I can do is drop into my terminal window here. I happen to be in the same file directory as that code. If I just do a directory listing, you'd see it's a conditional.py here. I want to make a really brief statement here, I guess, about the condition or the extension, the .py. Even though it's true that we could run this script, we could run this code without the .py, it's really important to put that on there. It does not really make this double clickable. That is to say, I couldn't just double click on conditional.py and it would go execute this in Python. That doesn't really happen. But it's a good clue for me to understand what the language is here. So .py is the classic extension for Python, like .php or .rb for Ruby. These other are important. I can use .csv or .tsv or .dat for different kinds of data files, for example. However, I just want to preface this and say, by the time we get to modules, Python will want that .py on there. So even if you feel that you don't want to put it on there, you want to be lazy, you don't want to put it on there, by the time we get to modules, it's going to be really crucial and really necessary. So I would just say, don't be lazy now. Let's put it on there and then we can work with them a little bit later. So if I want to execute this, I just tell the command line that I want to use Python. I want to use the interpreter, and I want it to use as input the following file. And I want it to execute the statements in that file as if they were Python, and they are. And so when I hit return, this is the execution of my script. Again, on line 5, it just prints to the screen, your name is, we see that. The conditional on line 7 is false, so we drop to the elif on line 9. That is also false, so we drop through to the else on 11. In the block there, and it's only one line long, that's line 12, and my script is the one that executes. So that's just one more way that we can execute Python code. I wanted to drop into the interpreter here for just a second and show you a couple of other things. So one of them is we can ask it questions like, is 5 the same thing, the integer 5, is that the same as the string 5? And you'll notice that Python says that that equivalence is false. Those two things are not the same. We could ask if 5 is not equal to the string 5, and that one happens to be true. So we can ask Python, like, what are the types of these things? What kind of thing is that? And you'll notice that that number 5 is of class int or integer. And I can actually ask it what 5 string is, and you'll notice it is class str or class string, right? Which is makes complete sense. But this is part of the reason why the integer 5 is not equivalent to the string 5, is because they actually have different data types. All right, well, that's it for conditionals. Next time we'll start to look at some more interesting data structures. Thanks.